This is the first assignment after the midterm exam that requires videos. The first question defines a kind of difference between two Wiener processes. It's like that: xt equals wt minus t plus 1 minus wt. And there are several questions regarding these stochastic processes. Let's look at the first. Draw some samples of xt. So I chose because we're talking about Wiener processes. We're talking about infinite times of coin tossing. So I assume two extreme conditions. One is all of the outcomes are the heads, and the second is all of the outcomes are tails. So in this case, you could see that the Wiener process of the first outcome should be like this, and it's a straight line with this k or very about the with this k equals to s, and the corresponding xt, obviously it's in this case it's the it's s, so it's actually a constant function. So it should be like the horizontal line. And the second, in the second condition, when all the outcomes are tails, we could get that the Wiener process will be like this from in the fourth quadrant, and it's a decreasing straight line. And so we get and in the second condition, the xt it's actually a function. It's also a constant function, so it equals to minus s. So the first question, and the second question asks us to do this exploitation of xt and the autocorrelation function of xt. So we're going to do this one by one. If we're going to do this exploitation, we're going to plug this xt with this concrete form. Let's see whether we can simplify this. So equals to, and the exploitation of the difference of the exploitation of two Wiener processes. And the Wiener process is actually the limiting condition of the random walk. So we make yt the random walk processes, because it should be x, but we already have x. So the limit of the random walk and all the limit of random walk, and we take the limit outside. This is actually an assumption, but we just take it for granted. And so the limit of these two, the difference of these two exploitation of random walks. And as we all know that the random walks have the exploitation of 0, so the answer should be 0. The second question, and the second, we're going to find out the autocorrelation function. Like we've done before, we plug this x with with respect to w, and when we get this, and we multiply these two polynomials, we're going to get 4 terms. And if we could recall the autocorrelation function of Wiener process that we have learned in our class, we could actually get this is just the Wiener process with respect to t plus 1 and t2 plus 1. So it should be minus 2 alpha. Alpha it's a with this alpha it's with alpha a constant, and this is the 2 alpha the minimum value of t1 and t2, and all these three we could just substitute these t1 and t2 with this actual variables, and we could actually get it's actually a summation of there are 3 terms, and each of term it's a minimum function. And if we could simplify this, we know that the minimum function can be written as a function of the difference of these two terms. So this is just a function of t2 minus t1, and this is the function of t2 minus t1 minus 1. Well, we could also it could also be written as f2 tau minus 1, and the third one is f3 tau plus 1. So this autocorrelation function is a function of the difference of these t2 and t1. So we get that their expectation value is a constant, which is 0, and the autocorrelation function is a function of the difference of these two times. So I've actually answered the first part of our third question. This is actually a Whiteside stationary.